Welcome students, welcome to our channel Infinity Scholars Hub. In today's lecture, we will be discussing the chapter Factorization. Factorization is chapter number 14 of class 8 and we will go into the detail of this chapter and we will understand this chapter properly. So let's start. So here we have the first slide. So basically we are going to see the introduction over here. See, we have learned how to find factors in arithmetic. Say for example, if I give you 6, okay, so the factors of 6 are, you can write 1 into 6, right? 6 can also be written as 2 multiplied by 3, right? So when I say the factors, so you can say 1 and 6, right? Same way in algebra also we have factors, okay, and the process of finding of these factors is called factorization, okay. So this is simply factors. Now let's take an example of an algebraic expression with one term, which is 5xy, okay. So the factors of this 5xy can be 5x multiplied by y, correct? I can even write this as 5y multiplied by x. I can even write this as 5 multiplied by xy, okay. So let's take some other number, let's say 12, okay. So I can write down the factors of 12 as 1 into 12. I can even write this as 2 into 6. I can write this as 3 into 4, right? So these all are factors. So we all have also learned about prime factorization. If I say the prime factorization of 12, so you can write it as 2 multiplied by 2 multiplied by 3, okay. So the prime factorization of 12 is 2 into 2 into 3. So this is called prime factorization because you cannot find out the factors further than this, okay, for the number 12. Same way in algebra also we have something similar to prime factorization, which is called irreducible form, okay, which is called what? Irreducible form. Now when I write this 5xy as 5 multiplied by x multiplied by y, this is irreducible form because you cannot find out the factors further than this. So there are three factors of 5xy, which are 5, x and y, okay. So this is called irreducible form. This is very much similar to the prime factorization over here. If you see properly, the prime factorization of 12 has 2, 2 and 3. So these factors cannot be you cannot find furthermore factors, okay. So irreducible form, the meaning of it is necessary for you to understand, okay. So I hope you all have understood this. Now going on to the next slide, okay, what do we have over here? See, finding factors. How do we find the factors? Okay, see, let's say the expression given over here is 2y plus 6, okay. So basically this expression contains two terms. The first term is 2y and the other term is 6, okay. Now we will write the irreducible form of each of this term. So the irreducible form of 2y will be 2 multiplied by y, and basically this is only a number, so we can say the prime factorization of this 6 will be 2 into 3, correct. Now that means both these terms are having 2 as the common factor. So how do I write? We have 2y plus 6, right? So what is common? 2 is common, and inside the bracket, see, in the first term I have y left out, in between I have a positive sign, so I will write positive, and on the second term I have 3 left out, so I will write 3. So when you factorize 2y plus 6, it will give you 2 into brackets y plus 3, okay. And if you do the reverse process of this, this is called expansion, or you can say you are expanding. For example, if I give you 2 and in brackets you have x plus 4, so what will you do? You will multiply this 2 inside, this will become 2x plus 8. So what you have done over here, you have expanded the given expression, okay. And if you go from this step to the first step, that means you have done factorization. So you have found out the factors of this expression, and the factors of this expression are what? 2 and x plus 4. Okay, same way over here the factors of the expression 2y plus 6 are 2 and y plus 3. Okay, now there is an example given to us over here. We will find out as they have told us to factorize, we will factorize. Okay, now see, 3x can be written as 3 multiplied by x. This is the irreducible form of the term 3x. In between you have a positive sign, so you will write positive. Now 18 can be written as 3 multiplied by 3 multiplied by 2, right? 3 3s are 9 and 9 2s is 18. So this is the prime factorization of 18. Now see, this is your first term and this is your second term. In both the terms 3 is common. So I will take out 3 and inside the bracket I will have x plus what is left out in over here, 3 into 2, that gives you 6. So the factors of 3x plus 18 are 3 and x plus 6. Okay, so this is how we factorize. Let's go on to the next slide then. Okay, now see over here what is given? Common factors. The factor which is common to both the terms or the factor which is common in all the terms is called as the common factor. Okay, but when we are finding out the factors or when we are factorizing, we are not concerned about only the common factors. We have to find out the highest common factor. For example, if I give you 4x plus 16, right? So if you look properly, 2 is the common factor, right? But we have to find out the HCF. The HCF of both these terms is what? It is 4, right? So see, if you write this expression as 2, in brackets you will have 2x plus 8, right? But the factorization is not over here because you have taken only the common factor and you have to take what? You have to take the highest common factor. So the highest common factor in 4x and 16 is 4. Okay, so if you want to know how 4, then see, look, watch over here. 4x can be written as 2 multiplied by 2 multiplied by x. Okay, in between you have a positive sign, so we will put plus, and 16 can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2. So now these are the factors of the first term, that is the irreducible form of the first term, and this is the prime factors of the second term. Now see, what is common? 2 is common, so I will write 2. One more 2 is common, so I will write into 2, right? Now inside the bracket, because there is nothing common left over here now, so x is left plus, so I will put positive sign and 2 2s are gives me 4. Okay, so this will be 4, in brackets I will have x plus 4. So this is now called the irreducible form. So the factors of 4x plus 16 are what? 4 and x plus 4. Okay, if you wish you can write this 4 as 2 multiplied by 2. So you can even write this as 2 comma 2 and x plus 4 are the factors of 4x plus 16. Okay, so we'll read this out once. See what is given. In the previous example we saw that 2y and 6 had a common factor of 2, but to do the job properly we need the highest common factor including any variables. Okay, so we have to find out the highest common factor. Let it be variable also. So in the case of variables also you will have to find out the highest common factor. Now let's go on the next slide then. Okay, so there are a few examples which are based on regrouping. Okay, see, whenever 4 terms are given to you, there will be a need of regrouping. Okay, first check whether without regrouping you are getting your answer or not. Okay, but if you are not getting your answer, then you have to do regrouping. So let's see, let's try out one sum out of it. So basically the first sum, if you see, it is given x squared plus yz plus y plus xz. Now if you observe properly, in these two terms, in the first two terms, if I take these two terms, there is nothing common in the two terms. Okay, so what will I have to do? I will have to shuffle the terms. There are 4 terms in this: x squared then next is yz, the next term is xy, and the next one is xz. So overall there are 4 terms. What will I do? See, I can bring this xy and I will send the yz over here. Let's see what happens. So I can write this expression as x squared plus xy plus yz plus xz. Now I will take two terms and find out common in them. So if I take the first 2 terms, x is common, so I'll write x. Inside the bracket I will have only x left, because over here it was x squared and one x is removed from here, so I will have only x in the bracket. You have a positive sign, you will put positive. Then you have xy, out of which x is already taken out common, so that means only y is left over here, so y, bracket closed. On this side, if you see plus, you will put a positive sign because there is a positive sign over here. Now in yz and xz, z is common, so you will write z outside the bracket. Inside the bracket you will have y plus x. Now you know that if you write y plus x or if you write x plus y, both are same, because we know that in algebra, algebra also follows the law of commutative. Okay, so when 2 variables are there, okay, so they obey commutative law for addition. That means y plus x can also be written as x plus y. Okay, so this can be written as x plus y plus z, and in bracket x plus y. Now see, note one thing over here. Initially in the question there were 4 terms. After factorizing, you converted them into 2 terms. Now see, again you can factorize this, because there are 2 terms right now over here. This is one term and this is another term, and in both these terms you have x plus y common. See, you have x plus y in this term and you have x plus y in this term also. So I will write x plus y in one bracket, and in the other bracket whatever is left out I will write that. So x plus z is remaining, so x plus z. So these are the factors of this particular expression which is given. So this is how factorization using finding factors by regrouping is done. Let's go to the next slide then. Okay, now we have factorization using identities. See, we know 3 basic identities. Okay, one is a plus b whole squared, next is a minus b whole squared, third one is a squared minus b squared. Okay, so we will try using those identities over here. If you pick up this sum, see, let me write this sum over here. It is 4x squared minus 9. Okay, so 4x squared, 4 is square of 2 and 3 is 9 is square of 3. So as soon as you see such numbers, generally square numbers, you should आपके दिमाग में आ जाना चाहिए कि we have to apply the identity a square minus b square over here. So I can write this as 2x whole squared, correct? Because 2x whole squared, if you expand it, it is going to become 4x whole squared minus 3 squared. Okay, so this looks similar to an identity which is a squared minus b squared. Okay, when you compare the two, you will find that your a is what? Your a is 2x and your b is what? B is 3. Now you know that the expansion of a square minus b square is what? A minus b into a plus b. Okay, so simply you have to replace a with 2x and you have to replace b with 3. Okay, and write the same thing as it is. So a, instead of a you have to write 2x. So 2x, in between you have a negative sign, you will put negative sign. B is 3, so you will write 3. Okay, and in the other bracket again you have a, so our a is what? 2x, then you have positive sign, so plus, and then you have 3. Okay, so the factorization of this particular expression is what? It is 2x minus 3 in one bracket and 2x plus 3 in the other bracket. Okay, so this was an example of factorization using an identity. Now let's take another example. Okay, so we have, let's take this one. So a squared minus 20a plus 100. See, generally when you have 3 terms, think of applying a plus b whole squared and a minus b whole squared. Okay, it would be related to this particular type of an identity. See, this 100 looks like 10 squared, or I should say it is 10 squared. So what can I do? I can write this as a squared minus 20a plus 10 squared. So when you compare this identity with a squared minus 2ab plus b squared, you can see that your a is you can say a or a, ठीक है, your a is a and your b is what, and your b is 10, ठीक है, तो a आपका 10 a है and b आपका क्या है 10 है. So we know that, okay, first we should write this particular expression in this form, ठीक है, तो a square तो है हमारे पास, it is there, okay, minus 2. Okay, so if I remove 2 from here, this will be 10a left. Okay, अब 10a है तो out of which a तो a ही है, okay, but b is 10, correct, plus 100 can be written as b 10 squared. This will be written as 10 squared. So now you can easily see that a squared minus 2ab plus b squared. So this is the expansion of a minus b whole squared. So we will write a minus 10 the whole squared. So this is the factorization of this particular expression given. Okay, fine. So let's go on to the next slide then. Okay, now factors of the form x plus a and x plus b. Okay, we have known this identity also, that when x plus a and x plus b is given, the expansion of this is x squared plus in brackets a plus b multiplied by x plus ab. So I will write it down over here. Whenever x plus a multiplied by x plus b is given, the expansion of this is what, x squared plus in brackets you have a plus b whole multiplied by x plus a into b, correct. So now see this expression, don't you think this is sum of 7 plus 3 and 21 is multiplication of 7 into 3. So that means your a can be 7 and your b can be 3, right. So let's write it down. First of all, let's compare the given expression to this identity. So x squared, so my x is what, my x is m, okay, so my x is what, my x is m. Now after that plus a plus b, so I considered my a as 7 and my b as 3, so I can write 7 plus 3 whole multiplied by, you have x, so x, in place of x we will write m because our x is what, our x is m. Then plus this 21 can be written as 7 into 3, that is, which is ab. So this can be written as x plus a and x plus b. So what is your x? Your x is m plus a is what, 7, so I will write 7 in one bracket, in other bracket x plus b, so it will be m plus 3. Hence this is the factorization of the expression given above. Okay, so in this video we will be discussing only up till here. I hope you have understood each and everything that we have discussed. If you like this video, you can like the video and subscribe our channel for more interesting videos. You can tell us in the comment section and we will be delivering those lectures to you. Thank you.